Okay, so tomorrow we are discussing about deformation, and we have discussed that we have two types of deformation. Deformation is actually a result of any external push, pull, or any type of force, even twisting, torsion, shear, or even bending, any compressive force or any tensile force, right? Any type of force which caused a deformation in the system. This is a deformation. Any change in the system, change in size, shape, or even direction. Okay, so further we have discussed about we have elastic deformation and plastic deformation. So what is elastic deformation and what is the difference between plastic deformation? Okay, elastic deformation. Just suppose if I have one spring, or suppose I'm taking more examples. Suppose I have a sponge or any rubber ball. If I pressed the ball or rubber or even a spring, it will change its shape. And when I remove the force, it will regain again its original shape. Okay, so this type of deformation is reversible. Once the force are no longer applied, the object returns to its original shape. But what about elastic deformation? This type of deformation is not reversible. However, an object is in the plastic deformation range will first have undergone elastic deformation, which is reversible, so that the object will turn apart away to its original shape. Okay, suppose we have taken example of a spring. Like here, that is the original length of the spring, right? If I attach any load with it, that is, load is actually acting like a force because weight is equals to force, right? So it is stretched somehow. You can see the change in the shape here, in the length. There is a change in the length, right? As the weight is increased, there is change in length. Weight of 1 Newton is introduced, and the change in length will be 10 millimeter, right? But what happened if I increased the load? I've increased the load by 2 Newton, and you can see that there is a change in length by 20 millimeter, right? But if I remove this load, it will again regain its original shape, that is the first one, this one. This is the example of elastic deformation. But what happened if I still loaded the spring more and more? Like this. If I still loaded the spring more, what will happen now? Now you can see here that my spring is look like it deformed. You can see that the spring is deformed now because I have introduced more weight that is more than its elastic limit. These weight are more than its elastic limit. After that limit, it has a limitation to work against the stretching force. Means after removing that weight, it will regain its shape. Means up till here, it has an elastic property. But after this limitation, it will not come towards its original position. Means after the removal of this force, even after I will remove that force, In spite of it, my spring remain in the same shape, size. It will not come back to its original size. So that is the state. This state is called as a plastic deformation, where object will not regain its original shape when we remove the force. Okay. Okay. Then we have done with this practical. Practically, we have done. There's an experience that what will be happen when we keep on changing different loads, different forces, and we have seen that there is a linear behavior between as we loaded the spring, the extension and the loaded force will be linearly moved. It will be linear until that point. Until that is x. So what is this x? That is the limitation point of the spring, and after that our spring become inelastic. So that is the point where my spring become inelastic. Up till from 0 to onward. Up till 0 to 4 Newton load, it has extension of 40 millimeter. But after this, my spring has a no more flexibility to extend more extension, right? So we have done this tomorrow, and we have done with this class as well. And we have studied that what is the elasticity limit, that is the constant for every material, even it is a spring, even it is a rubber, or even if it is any steel rod, or even if any iron rod, every elasticity limit having a different with different materials. So it is actually the material property. You can say that it is a material property. It is based on the material. Every material have different elastic limits. Okay, so actually the main law which govern with this whole deformation or elastic properties is actually Hooke's law. So what does the Hooke's law state? So this is the today's topic that we are going to start. So Hooke's law state that the extension of a spring is proportional to the load. How much the spring or whatever the object is extend, it must be proportional to the load we have applied, provided that the limit of proportionality is not exceed. So the Hooke's law is actually saying that the same thing with what we have experienced. Extension of the spring is depending on the applied load until the limit will not exceed. So that is the Hooke's law. So what is the formula for this is force is equals to, because it is directly proportional, force is directly proportional to the displacement in a spring, right? Unless there is elastic limit is not exceed. So there is a limitation. What is the limitation? Elastic limit should not exceed. Force will be directly proportional to the extension of the spring. You know that the force is whatever you are applying, even it is a weight or any load. X is the stiffness of spring. Okay, that is the property of the material, and X is the displacement, is the extension of the spring. Clear? Yes, students, is that clear? Yes, Amara. Soha, Azan, Mariam, Taima. Is this clear to all of you?
Yes, miss.
Everybody of you?
Yes, miss.
Okay, so here we have some numericals for by using we can solve these by using the formula above, that is the Hooke's law formula. F is equals to kx, right? Okay, but for now we don't know that what is the constant value of constant. I will provide you the value of constant and try to solve these formulas. Okay, what you have to do, a helical spring of a natural length. Okay, the natural length, that means the natural length of the spring, because you know that every spring has certain natural length. It's 20 centimeter, right? That is the natural length. Okay, now it is stretched to 24 centimeter. Now, by applying the force of 20 Newton, now the spring is stretched till 24 centimeter, right? What force is required? Now they are asking for you what force is required to stretch this spring to the length 30 centimeter, right? अगर हम स्प्रिंग को 30 सेंटीमीटर तक स्ट्रेच करना चाहते हैं तो हमें कितनी फोर्स की जरूरत होगी? You have to calculate this. यहाँ पर आपको ओरिजिनल लेंथ आपको पता है, आप क्या करोगे? आपको एवरी टाइम आपको ओरिजिनल लेंथ में से आपकी जो लेंथ है उसको माइनस करके निकालोगे. जैसे यहाँ पर अगर है तो आप क्या करोगे 24 माइनस 20, और जहाँ पर 30 सेंटीमीटर है तो आप क्या करोगे 30 माइनस 20, and then you are going to use this formula. I will give the value of constant to you, then start doing it. इसको आप अपना ऐसा होमवर्क करना. फॉर्मूला आपका है k and x. So वैल्यू ऑफ x आप कैसे निकालोगे, मैं आपको ये बताना चाह रही हूँ. वैल्यू ऑफ x आप इस तरह से निकालोगे, आप करोगे आपकी ओरिजिनल लेंथ जो आपकी L2 है, दैट मींस 30, तो आप माइनस करवाओगे L0 से. L0 क्या है 20, तो आपकी x आ जाएगा, राइट? फिर आप यहाँ से कैलकुलेट कर सकते हो अपना फोर्स. ओके, अपनी आप फोर्स कैलकुलेट कर सकते हो. x is constant. You can search this value in the Google as well, that what is the spring constant, k, value of k. I will search this value and send it to you, right? Similarly, you have to do the same for all of this. Okay, any problem? Yes, Mariam, Amara, Saima, Azan, any problem?
No, miss.
Okay. Okay, for tomorrow you have to keep one graph with you as well, right? At least 2 graphs with you, because for tomorrow we are going to do this plotting as well, and you have to do these numericals as your homework, right? And for today I'm going to share one video with you. Okay, look at this. Elasticity. Okay. Whenever you think about elasticity, you have a concept in your mind that whenever you are stretching anything, that means this is the elasticity. This is the spring that we have done with. Okay, whenever you apply a force in the helical spring, it definitely deforms, but after some time it can regain its shape. So the force you are applying is actually a deforming force. Okay, so what is elasticity? Ability of a body to regain its shape after the removal of force, that is elasticity. Similarly, we have these two other examples as well for this. Sponge ball and the rubber. Okay, so up till here we have done with the elasticity of object, but definitely there is a limit for this. So what is the limit here? Object remain elastic forever? No, there is some limitation as well. Now you can see that it is stretched a lot. Now it has no more elasticity because it crossed from it limitation, or even it gets broke as well. So that is the permanent deformation. It's called plastic deformation, as we have done. Okay. Now suppose I have provided you one rubber spring and one steel spring, right? Now, what happened if I applied a force on both of them? Both are identical to each of them. Okay, I am stretching both the sides with the equal forces. Now look what happened. Okay, just tell me which one is stretched more. Just give me an answer. A rubber or a steel? Which one is stretched more? A rubber or a steel? Yes? Yes, students. Which one is stretched more? A rubber or a steel? Yes, Mariam, Zoha, Saima, what do you think? Which one is stretched more? Mera?
A string.
Yes? Which one is stretched more? Sorry, you're not audible.
मिस आप स्क्रीन वापस से शेयर कर सकती हैं?
Screen is not visible to you.
नो मिस,
Okay, just a
ब्लर नजर आ रहा है.
okay, now tell me, is it visible to you?
नो मिस.
Let's share the screen. Maybe it takes some time. Visible or not?
नो मिस. नो मिस, मेरी डिवाइस में विजिबल नहीं हो रही.
Not visible. I have again shared the screen. And
I think मेरी डिवाइस में मसला है.
बाकी सबको विजिबल है? Azan, Soha, Maryam.
Yes, Miss Clear.
मिस मैं वापस ज्वाइन कर लेती हूँ.
Okay, right. Okay, so I'm asking you a question that if I have one rubber spring and one steel spring, and if I applied a force on both of them of equal magnitude on both these sides, so which one is stretched more? A rubber steel or a steel spring? Which will be stretched more? Yes, Azan, what do you think? Miss Mariam?
Uh, the left one.
Rubber. So you said the rubber will stretch more. You're right, the rubber will be stretched more. But let's see what will be happening. Rubber will stretch more further. And steel string is harder to stretch. But what will happen? Okay. But actually there is a difference between the elasticity and flexibility. A rubber is more flexible as compared to the steel. Actually, steel is having more elasticity. What is actually elastic? Elasticity. What do you mean by the elasticity? Actually, steel is more resistant material. Means it doesn't allow the forces to change its shape more quickly. It will be changed its shape, but less as compared to the rubber. Rubber is more flexible but not elastic, right? So don't be confused in the two words flexible and elastic.